So hello guys, welcome to my YouTube channel again, and today I will be discussing the Leet Code Daily for 2nd of Feb, and the question name is verifying an alien dictionary. So I'll advise you to first go through the problem statement, try it yourself, and then if you face any difficulty, see the solution. Also, if you have solved the problem, then also go through the solution. Maybe you find some other approaches. So in the question, basically we will be given that in an alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. So here the alphabets are in a different order. The order of alphabets is some permutation of a lowercase letters. Like if you can see, this is the order. So in this dictionary that the aliens are using, this is that order. H is the smallest character, then you have L, then you have A, then you have B. So this is the order, and given a sequence of words written in that language, and the order will be given and some words will be given. So return true if and only if the given words are sorted lexicographically in this alien language. So basically we have to tell whether the given words, like words is a array, like it is a vector of all the strings. So we have to tell whether this order, this hello and this leet code, whether this order is lexicographically sorted or not. Lexicographically sorted means basically it is the dictionary order. So if suppose I give you an example, if we consider our our language ordering, A B C D E F, okay, if this is the ordering that we have, like this is the general English ordering, then we will say that A B C, and suppose we take A D A, okay, so this A B C will be present at a lower position than this A D A. Why? See, look at the first character, A and A are matching, so we cannot make any judgment. But at the second position we have B, and here at the second position we have D. So if we compare the B and D, then the B is lesser than the D. So if at any point we get a character which says that which is different in both the strings, we can then and there decide whether which is lexicographically smaller. So if in the first string this position is lesser, the B position, if you look in the alphabet, what is the position of B? So if I do the zero based indexing in the positioning, it is 0 1 2 3 4 5. Okay, let us consider we just have 6 characters. So the position of B is 1 in the alphabet's order, and the position of D is basically 3. So the one having a larger value of index here is present at the right and is greater. Okay, so at the first position here, first position I am considering here 0 based. Okay, so 0 1 2. Okay, so here at the first position B is present, at the first position D is present, and the position of B is lesser and then the position of D in the dictionary, or like in the order. So we can very well see that this ABC is lesser than ADA. Okay, this I am talking about this ordering, the ordering that we follow in our English language. Then let us consider another string, and they can be of different lengths also, that is not a problem. Like suppose there is a E here, and suppose there is a E again a C here. So here also, since at this position we found a differentiating factor, we can say that here also ABC EC is lesser than ADA. Then let us consider another string. Suppose here there was a E. Okay, so at the first position there is a E. So in the first string there is a E here, but in the second string there is a D here. A and A are same, so we cannot make any judgment here, but here it is E and here it is D. We know that E is greater. As you can see, E is greater than D, because the position of E is more than the position of D. The position of E in the ordering is 4 and the position of D in the ordering is 3. So we can very well see that this AEC is AC is greater than ADA. Okay, so as soon as we get at a particular index, as soon as we get a character which is not equal in both the strings, we can then and there decide which is greater. If the position of that character in the ordering is greater, then we say that is greater. So here D was greater, so we say that this is greater. Here E was, the position of E was greater, so we say that this is greater. There may be a case where you say that where you have this A B C, then A B C E D. So now you don't have a differentiating factor. A are same, B are same, C are same. Okay, at the 0th position, if you consider 0 1 2 3 4, so here at the 0 position, A are same, B are same, and C are also same. So here how we will decide? Here we will decide by the length. If at all the positions the characters are same, okay, till we can compare. Here we cannot compare the 3 position because third index do not exist in string 1. If in this case the one with a larger length is greater, so here this is greater than ABC. So basically these are the rules for lexicographical ordering that we have. Like, this is also known as dictionary ordering. So just that you have to tell whether it is sorted lexicographically or not. Just that here we don't have this ABCDE. Instead of this ABCDE, we are given an ordering. Okay, this ordering is given here. They will give you order which alphabet is smaller, which alphabet is greater. Okay, this is the only difference, and the rest of the things remain same. We have to check whether it is lexicographically sorted or not. So in order to check that, see, first how to deal with this order. So in order to, we have to, while checking the words, we have to check whether which alphabet is greater and which alphabet is smaller. This we have to check. So how we will check which alphabet is greater and which alphabet is smaller? We'll check by the position of this alphabet in the order. So if I do the indexing of this string 0 1 2 3 4 5 6 7 8 9 10, then 11, then 12, then 13, and so on. This will be go on till 25 because we have 26 characters here. So if you compare, whether you compare this you compare this H and G, so which is lexicographically greater, or which character is greater? So here the position of G is 8 and the position of H is 1. So the one having a greater position in this string is greater. This is the order given to you. This order means that thing, that if a character is present at the writer part, it is greater than the present at the lower part, basically. Okay, so using this positioning, we will compare two characters, which is greater and which is smaller. Okay, so this is how we will handle this order case. Then how to check for given this sequence of strings, how to check whether this is lexicographically sorted or not. So suppose I am saying that I am giving 3 strings, str1, str2, str3. If I am given these 3 strings and I have to check whether it is sorted lexicographically or not, so what I have to do, this str1 should be smaller than str2 and also smaller than str3. So this str1 is smaller, right? So str1 should be smaller than str2, also str1 should be smaller than str3. Or suppose let us take 4 strings here, str1, str2, str3, str4. So since this str1 is the smallest, this str1 should be lesser than str2, this str1 should be lesser than str3, and this str1 should be lesser than str4, then this str2. So since this str1 is the smallest, it has to be smaller than all of these. Now str2 should also be smaller than all the strings present to the right of it. So str2 is lesser, should be lesser than str4. Similarly for str3, it should be lesser than str4. How we will check lesser and greater? This we have already discussed. If at a one point we get a different character, we can then and there decide which is smaller and which is greater. If at all the positions we get the same character, then we'll decide on the length. Okay, so this is that ordering that I already discussed. Okay, how to check between two words, which is greater and which is smaller. Okay, and this is how we will handle the ordering thing. This, and in order to decide the lexicographically ordering of the words, we have to decide on this. But if you look here we are comparing str1 with all the str2, str3, str4. Here we are comparing str2 with all the strings present at the right of it. This approach will work because here n is given to you as just 100. So here it will be just 100 square into the length of these strings. So the length of these strings is nothing but 20. So here it will be nothing but 100 square into 20. Okay, since you are checking for all the pairs, right? So it will be n square into the length of the string. So it will length of the string. So this will be the time complexity if you follow this approach. So I'll ask you to first implement this kind of a brute force solution, which is checking the lexicographical ordering. But I am saying that you don't have to do it. Okay, you can very well see that in order to check for the lexicographical ordering, what you can do instead is just compare str1 with str2, then just compare str2 with str3, and just compare str3 with str4. If you just compare the adjacent characters str1, str2, str2, str3, str3 and str4, if you just compare these three, then this comparison will mean exactly the same as this. How? See, str1 is less than str2 if you prove this. Then if you proved this, also you prove that str2 is lesser than str3 and str3 is lesser than str4, then see, here you can say that str1 is also less than str3, because see, str3 is greater than str2, and this equation says that str1 is lesser than str2. So this str3 is greater than this. So this str1 will be smaller than str3, obviously, because since str1 is lesser than str2 and this str2 is lesser than str3, then I can say that str1 is lesser than str3. Also, using the same analogy, str1 is lesser than str4 because str4 is the greatest out of all. Okay, so since str1 is lesser than this str4 and this str4 is greater than this str3, so this will automatically mean that str1 is also lesser than str4. Similarly, here also str2 is lesser than str4 because str2 is lesser than str3 and str3 is lesser than str4. This str4 is the greatest. So here it will automatically mean that str2 is lesser than str4. So here we are just comparing these three, we are getting all of these equations. So that is why it will suffice to just check the adjacent strings. So you just check for the lexicographical ordering, just check whether str1 is lesser than str2, whether str2 is lesser than str3, and str3 is less than str3. Just do the 3 comparisons between adjacent, and if in all the 3 comparisons you get this result that the previous one is lesser than the one present at the right, if for all the i's you have this condition, you are able to get this thing, then you can say that it is lexicographically sorted. Otherwise you have to say that it is not sorted. So this is with the basic logic, and let me just quickly code this, and the complexity of this I will discuss. But since we are comparing only the adjacent, so there will be just n-1 comparisons, and in these n-1 comparisons we will have to iterate over the length of string. So if we have to, like, I am doing just n-1 comparisons here, and in these n-1 comparisons I have to do length of string. So it is just n into length of the string, like order n-1, we neglect the constant terms in the time complexity, right? So this is just n into length of string, so it will be just 100 into 20. So this is that optimized approach. So I'll be just coding this optimized approach. If you want, you can code this also. Both are just similar, just that in the brute force approach you have an n square loop. In the optimal approach you're just checking the adjacent, so it is an n loop. Okay, so this is that. Now just let us just code this. So first we have to create, in order to compare the words, in order to compare the words, we will need to find position of characters in the order. So in order to check the adjacent words, whether which is smaller, which is greater, we have to find the order, like at which index this A alphabet is present, at which index this E alphabet is present, so that we can compare the two values. So we will have one map. You can also make a array of size 26, or I am making a map of size 26, it hardly matters. Okay, so this will store the position of a character in this order. Okay, so we'll just iterate over the order. I is equal to 0, I less than, the order size will be 26, as there are 26 characters. I is equal to 0, I less than 26, position of that character is nothing but order of I is equal to I. Okay, so now we have to check for all the, now we have this odd position stored for every character. Now we will check for all the pairs. So how to check for the pairs? We'll start our I from 1, and we'll do I less than words dot size, because we have to check for every adjacent. So here we will check the adjacent pair I minus 1 and compare the I minus 1 with I, and we have to prove that for every I minus 1, for every I minus 1 should be lesser than this I. So let us store the string str previous. Str previous means this I minus 1. Okay, so that we don't have to write words of I minus 1 each and every time. So I am storing it in one of the string str previous. We will replace this after doing the code. Okay, then string, this is the previous and this is the next, so words of I. So now I have to compare this str previous and str next. Str previous is nothing but I minus 1th word, and next is nothing but ith word. So now you have to just prove that this str previous is lesser than str next. So how can we prove this? So as I said earlier, we have to just iterate over the length and find one position at which it differs as starting from the 0th character, because lexicographically sorting means it is starting from the 0th character. The dictionary order starts from the 0 character itself. So we will check, as soon as we find one differentiating factor, we can directly make, depending on where it is present in this ordering, we can directly tell which one is greater, which one is smaller. So let us just iterate j is equal to 0, j less than, since we cannot go out of bounds here because these are two strings, whichever is the smaller string we will have the characters till that position. So you can replace this str. Okay, this is the previous and this is the next. So this is previous dot size comma next dot size. So this previous dot size and next dot size, we will go to the minimum of these, because we will go to the minimum, because if we will exceed the exceed one of the length, then we will definitely get out of bounds. Suppose this is of length 5 and this is of length 3. So if we go beyond this 3 and try to access this character, then it will be out of bound, right? So that is why we go till minimum. And in this check variable, we will store it is initialized with -1. -1 will signify that I haven't got one differentiating factor, so not found. This -1 will signify not found. 1 will signify that yes, it is true that previous is lesser than the 6, and 0 will signify that previous is greater than the next. So 0 is kind of false. Okay, like this we are just storing, like making one check. This check can be in 3 states -1. So in this case it will be -1, this ABC and ABCED, because you will go till the 2th index, because the first string is only of length 3, and here you will not find any differentiating factor, because A is equal to A, B is equal to B, C is equal to C. Here you will definitely find a differentiating factor, E and D. Here there is a differentiating factor, but here there is no. So this check equal to -1 will signify whether we have found a differentiating factor or not. Then other than that, if the check value is 1, then we have found the differentiating factor, but previous is lesser than the next. That means we have found a character such that the position of that character is lesser than the position of the character present at next. So position at the previous, this is just a pseudocode, okay, is lesser than the position in the next in the ordering. And here it will mean that the position of previous is greater than the position of next. Okay, so let us just compare. So if previous of j, so this previous of j is the character at the previous string, like I-1 string. If it is lesser than the next of j, that means in the previous string, that is I-1th string, there is one character. Okay, but let us first extract the characters. Okay, character previous character is equal to previous of j. This is the character present at the jth position in the previous string. And next character, this is the character present at the jth position in the next string. Like this is the I-1 string, and this is the ith string, and at the jth position, this is also the jth position. So now we have the two characters. Like if you look here, I have the two characters B and D. Now I have one differentiating factor, but B and D, we cannot say that B is lesser than this D. Okay, it depends on this ordering. Here the position of B is 3 and the position of D is 5. So here we can say that yes, B is lesser than D, because B is present before D in the order, so B is lesser than D. So here we will say that yes, this string is lesser, like ABC is lesser. But suppose I give you the ordering like this. Instead of B here, I will do D here and I will do B here. Now the position of B is 5 and the position of D is 3. Now I cannot say that B is lesser. B is greater because the position of B in the order is greater. So I will have two variables here, like int position of previous is equal to, in the map we have the position, right? So position of previous character. So this position previous is like previous position is the position of the character, like position of the character pre-char in the order, because map stores the order, right? This map position, this stores which character is present at which position. Then this next position, this is nothing but position of next character. So this is nothing but the position of the character next char in the order. Okay, now see, if the two characters are different, then only we can compare. So if previous character is not equal to the next character, if they are equal, then we cannot do anything. Okay, then we have to just move ahead, like ABC we cannot do anything, A we cannot do anything. We have to find one differentiating factor. If they are not equal, then we have found a differentiating factor. So found a differentiating factor. Differentiating factor means they are different at that position, so we can decide different at the jth position. So I can now decide which is lexicographically smaller or which is lexicographically bigger. Basically I can decide which is less and small. So here I can decide which is less and which is the bigger one. Okay, so now if previous position is lesser than the next position, then I can say that previous is lesser than the next. Basically previous position, that means here if you have B, the position of B was 3 and the position of D was 5. So here I can say that this B was present in the previous and this D was present in the next. So here this 3 and 5, so 3 is lesser. So I can decide if 3 is lesser, previous position is lesser than the next position, then I can say that at this index there is a differentiating factor and this position makes the previous string lesser than the next string. Okay, so we can have, and what is that we have check is equal to 1 for that. Okay, so we will directly do check is equal to 1 and then we'll break, because we have found the differentiating character. Now I don't want to iterate over this. As soon as we get an ordering, we will just break out. In the else case will mean that previous position is greater than next position. Here you will not get the case previous position equal to the next position, because previous character and the next character are different. So if the characters are different, the position will be different. So here if you have previous position less than the next position, so here you will have the previous position is greater than the next position. So if the previous position is greater, that means the previous string is greater. So here the previous string is greater, so we will do check is equal to 0 and we will do break. Okay, so as soon as you get a differentiating factor, you check the positions depending on which is at the lesser position, which in the order you decide which string is greater, which string is smaller. Okay, so if you are out of this loop, then you will have check, where the check will be in 3 states: -1, 1 or 0. If the check, now we will have like this: if the check is equal to -1, that means that we haven't found a differentiating character. So then we'll compare on string length, like ABC and ABCED. Now the one with a greater string length will be the greater. Okay, so if previous dot size is lesser than next dot size. So if previous size is lesser than next dot size, then what we will have, then this is the case, right? So then we will do check is equal to 1. Check is equal to 1 means previous is less than next. Else case, in the else case, we'll have that previous size is greater. Okay, previous size is greater than the next size. So that means that next is greater than the previous. So we'll directly do check is equal to 0. Okay, so if check is -1, then we have to handle separately. Now after doing this, you will have check is equal to 1. That means your previous is less than the next, or you will have check is equal to 0. That will mean that previous is greater than the next. If check is equal to 0, then you have found one adjacent character which is breaking the order. So we were having the string 1, str2, str3, str4. So if suppose this is valid, this is also valid, and at this position we found a invalid case, that this string 3 is greater than the string 3 is greater than this string 4. So here it will make the ordering improper. So if at any place we find that the ordering is not proper, then we'll directly return false from here. So if check value has become 0, so we'll directly return false from here. After this for loop is over, we have checked for all the adjacent words. At the end we'll directly return a true. That means that we haven't found any case like this, and all the strings are like, all the adjacent are at the valid position, like the str2 is greater than str1, str3 is greater than the previous, str4 is greater than the previous, str5 is greater than the previous. So this is that. So now let us run this. Yes, it works. Okay, so hello, I was returning false and the expected is true. So we can have equal characters also. So in order to handle the equal case, I have said that, see here, previous dot size is lesser than, I have just written lesser than. So if it is equal also, it is fine. So if previous is less than equal to the next, that is also fine. So now let us check again. Yes, so it works. So this is that optimized approach. And here if you will look at the space complexity, this is just 26 space, so it is counted as constant space. Okay, and then the space we are not using anywhere. These are just variables that we have used inside. For explanation purpose, you can get rid of these also, but it is better for explanation purpose. If you are in an interview, it is better to name the variables properly. Okay, so this is that. So the space is of 1, and the time complexity we are checking for adjacent pairs n-1 times, and checking, like the checking is taking place in the previous dot size, next dot size. So this is nothing but your length of the string. So this is nothing but length of the string, and then this is nothing but n times, like n-1 times. So it is like n-1 into length. We can say that it is n into length. So this is that. So the time complexity is nothing but n into length of string, and the space that we are using, that is O of 26, or O of 26, because we are having a map of size 26, but 26 is a constant, so you can say that it is O of 1. Okay, if you want, you can have this, like if someone will say that it is a map, so searching from here will take log of 26. Yes, it will take log of 26, but log of 26 is also a constant thing. If you want to remove this, you can have one integer position also, integer position of size 26. This is also fine, but just for clarity I have used a map here. Okay, you can get rid of this, use this instead of storing this in strings previous and next. You can directly copy this here, like writing like this, previous of j. Instead of the previous, you can have words of I minus 1 j, and here instead of this position of previous character, you can have previous of words of I minus 1 j, and then you will not need this. So instead of this, you can have just this thing, like you can compare. But this is basically not that easy to understand. So we are having first words of I minus 1, we are taking the jth character out of it, then we are finding the position. So it is better this way. That is why I have taken variable names and done it. So if you are in an interview, it is better that to do it like this. If the interview says that why you are taking so many variables, then you can also remove this and show that yes, I can do it like this, but for understanding purpose I am doing like this. Okay, it will not impact the space and time complexity, it is just for the explanation purpose. Okay, so this is it. So thank you guys for watching, and if you like this solution like video tutorial, then please like, comment, subscribe my channel, and also follow me on Instagram, LinkedIn. I will attach the links in the description. If you have any doubts, feel free to ask in the comment section. I will be really happy to help. Okay, so thank you guys. See ya.